using triangle inequality to determine possible lengths of a third side. All right, so we already did a video on triangle inequality theorem. So the triangle inequality theorem, which they do state right down here, states that the sum of the lengths of any two sides of a triangle must be greater than the lengths of the third side. So if we know that we have to, if we add 19 and 20 together, these two added together have to be greater than x. So they come up with these three inequalities. So they have x plus 19 is greater than 20, x plus 20 is greater than 19, and also 19 plus 20 is greater than x. So the reason that we want to come up with these three is so that we can narrow it down, because our answer is going to be between two numbers. It can be anywhere between this number and this number. Like there's a range that it can be. It's not going to be one number for certain. It can be anywhere between the lowest possible number to meet these inequalities and the highest possible number to meet these, all three of these inequalities. So then they go through and they say that x must represent a length. It must be a positive number, so we don't learn anything from the inequality x plus 20 is greater than 19. And part of that is because 20 is already greater than 19. So we don't really learn very much from this one, because this could really be any number greater than 1, basically. Once you come over here, actually, no, I'll do it this way. So I'll explain it like this. So if you have x plus 20 is greater than 19, because it's already greater than 19, if I were to subtract like this, x would come down, 20 minus 20 goes away, and this is greater than, this is negative 1. Well, x can't be negative 1. That's why we don't learn anything from it. So that's a better way to describe it. It is because 20 is bigger than 19, but it's also because if we work this out, we get a negative 1. Well, we can't have a length that's negative. It's not allowed. It just doesn't make any sense. If I were to measure something and tell you, oh, it's negative 1 inch, you'd look at me like I was crazy, because that doesn't make any sense. So we ignore this one because it would give us a negative. So if you recognize that right away, great. If you don't recognize that and you end up getting the negative, just cross it off and ignore it after you've recognized it. So they're going to focus on these two. And they show you right away, we can rewrite these inequalities as follows. So we have x is greater than 20 minus 19, and x is less than 20 plus 19. So all they did was they subtracted 19 from both sides. And this one, they didn't really change anything. They just flipped it. So they moved x to the left side and 19 plus 20 over to the right side. So that's all they did on that one. So then if you do 20 minus 19, you get 1. And if you do 20 plus 19, you get 39. So our answer for x can be greater than 1 and less than 39, and it still meets this inequality theorem. So it has to be somewhere in between here. It can't be 1, it can't be 39, it has to be in between those two numbers. So it has to be greater than 1 or less than 39. All right, so let's go ahead and clear and actually start. All right. So then we write our three inequalities, because remember, it needs to be greater than any two sides. So we have 15 plus 17 has to be greater than x. We also have 15 plus x. Oops, I forgot my plus sign. Plus has to be greater than 17. And 17 plus x has to be greater than 15. So this is that situation where you'll end up with a negative. I know that because 17 is bigger. So if I subtract here, this is 0, x comes down. I have x is greater than negative 2. Well, my length can't be negative 2, so I ignore that. So if you recognize that, you don't have to do it. So now we're going to do these two. So we have 15 plus 17. That gives us, let's see, 12 and 32. So 32 is greater than x. And then for this one, I'm going to subtract 15 from both sides, because I want to get that x by itself. 15 minus 15 goes away. And I have x is greater than, and I just subtract, and I have 2. So remember, we want to put this in a sentence where x is in the middle. So I'm going to start with 2. And this is pointing at the 2, right? So I want it still pointing at the 2. I'm just switching it around so that x can be in the middle. And then here, it's pointing at the x, which is actually what we want it to do right here. So we're just flipping them around, just make sure that it's pointed at the same thing it's pointed at. So even though I flip this around, it's still going to mean the same thing. So this is 32 is greater than x. I'm saying x is less than 32. So I'm just reading it the other way. X is greater than 2. 2 is less than x. So it means the same thing. I'm just flipping it around so that I can fit it in the sentence because that's how they want me to write it. So now I come down here and I'm going to go 2 is less than x, which is less than 32. So again, that just means that my answer has to be between 2 and 32. Can't be 2, can't be 32, has to be between those two numbers. Check, and we get it. All right, we'll do the next one in kind of a dark green here. Next. So, all right, so I'm going to start with my 2. So I have 16. Whoops, help if I hit the pencil tool here. 16 plus 20 is greater than x. And then I also have 16 plus x is greater than 20. Now remember that third one, which I'll just write down here. We'd have 20 plus x is greater than 16. I know right away this is bigger than 16, so when I subtract, that's going to give me a negative. So I'm going to ignore it. Because like they said on that first one, we don't really learn anything from this one because it doesn't make any sense. Can't have that negative length. So I'm going to add these together and I get 36 is greater than x. And then this one I'm going to subtract. I end up with x. 16 minus 16 goes away. Then I subtract here and I get is greater than 4. So remember, I want x in the middle. So I want to start with my 4 and I want to end with my 36. So it's open to x, it's pointing at 4. I want to do the same thing. Open to x, pointing at 4. This is open to 36 and pointing at x. Open to 36, pointing at x. So I can rearrange that sentence really quickly. I just have to make sure I put them in the same, not the same orientation as far as like greater than less than, but the same part is open to the number and closed to the variable or vice versa, however it ends up. So we always want to make sure that we write it in the correct way so that it still makes sense. So 4 is less than x, which is less than 36. So my answer has to be somewhere between 4 and 36. All right, one more. Let's do this next one. Kind of a hot pink here. All right, next. Okay, so this is our last one. So we have 13 plus 17 is greater than x. Or we have 13 plus x is greater than 17. Again, I don't have to write the other one. That would be 17 plus x is greater than 13 because that would give me a negative. I can just ignore that one. So I'm going to add these two together. I get, let's see, yeah, 30 is greater than x. And this one I'm going to subtract 13. And those cancel out. 13 minus 13, x comes down. And that's greater than 4. So again, I want x in the middle. And I want to start with my small number and go to my big number. So I have 4. It's open to x, pointing at 4. Open to x, pointing at 4. It's open to 30, pointing at x. Open to 30, pointing at x. So I'm making that a little silly the way I'm saying it, but I want to make sure you understand how to flip those around. So I have 4 is less than x, which is less than 30. All right. And we finished that one.